All right, everyone. So today, for this video, we're gonna do another chapter 6 topic on molar mass and molar-mole ratio. So that's gonna be a new topic for you guys, molar-mole ratio. You guys already know molar mass, but we're just gonna do more with it. For example, you guys already know the molar mass of a single atom, like carbon, right? You can look this up on your periodic table. It's the little number that's right below carbon. And a good general rule of thumb is just to report to 2 decimal places. So you can round these longer numbers to just 2 decimal places, and you're good for the molar masses. Okay. So for carbon, it's 12.01. But you guys got to remember that molar mass, what that means, right? Um, Molar mass, just as it sounds, is the mass of 1 mole of something. So we're talking about carbon. The mass of 1 mole of carbon is 12.01. And what is that mass unit? It's grams. So the whole unit is 12.01 grams per mole. Okay. And remember, anytime that you see this slash here, that's the divide sign. So you can rewrite it as a conversion factor, right? Per 1 mole. Okay, so this would be carbon, right? There's in 1 mole of carbon, it should weigh 12.01 grams, right? So it's a way of counting by weighing because we can't see carbon atoms, right? They're too small. And so we are counting them by massing it out instead. And you guys remember what 1 mole meant, right? 1 mole is the chemist dozen. It's 6.022 times 10 to the 23rd atoms of carbon. So we've just lumped all that, right? Because atoms are really small. So we just grouped that number of atoms and we call it 1 mole. Okay. So 1 mole of carbon then weighs 12.01 grams of carbon. That means you can just go to the scale. And when you put this much, 12.01 grams of carbon on the scale, you know that this is how many carbon atoms you have, right? And so that's what the molar mass is used for. And you should remember the units, right? It's grams per mole. Now you could also write it like this, right? 1 mole of carbon over 12.01 grams of carbon. It doesn't matter how you write it for the conversion factor. It's equally useful. It just depends on whether you are going to convert from mole to gram or gram to mole, right? So you're going to be using both. Okay, so let's do now an example. Let's say we want to find the molar mass of something bigger than just an atom, like of a molecule. So CO2. Okay. CO2 is carbon dioxide, right? We got 3 atoms there. So we would need to sum up the molar mass of each individual atom in order to get the molar mass of the entire molecule. Makes sense, right? The sum of the parts is equal to the whole. So we already know carbon's molar mass. Oxygen's molar mass is 16.00 grams per mole. Right? You can, again, can get that from your periodic table. Okay. So to get the molar mass of CO2, all you need to do is take 12.01 plus 2 times oxygen's value, which is 16.00, right? And you're going to get, that's 32 plus 12, 44.01 grams per mole for CO2. Okay, so simple as that, right? So it doesn't matter which, what you're presented with as your chemical formula. You're just going to add up each individual atom's molar mass, and you'll get the whole molecule's molar mass. Okay. So now that enables you to do, certain calculations like, if I have 2 moles, let's say 2.0 moles of CO2, okay? How many grams of CO2 is that? So we can ask that, right? So converting from moles to gram. Well, if in 1 mole there's 44.01 grams, in 2 moles there should be twice that. right? So in this case, you could basically do this in your head, right? 88.02, right? But it's important to show how you set it up in your head, right? How is it that you guys come up with 88.02? Well, desired unit should be on top, and you want grams of CO2, so 44.01 grams of CO2 on top, and 1 mole of CO2 on bottom. Right? And we've talked about this before, right? In doing conversions, you want your desired unit on top, okay? So that's how you get that value of 88.02, because you're taking 2 times 44.01. Okay. Now, to the correct number of sig figs, you only have 2 here, so you could round this to 88, right? Would be the correct answer to 2 sig figs. Okay. Now you could do it the other way around too. Let's say that the question asks, if I have 101 grams of CO2, how many moles of CO2 would that be? Okay, so now we're doing the opposite, right? We're going from grams to mole. Well, we're going to set up our conversion factor. Okay, we need moles on top. Okay, so it's going to be 1 mole is on top, and the other side is 44.01 grams of CO2 on bottom. Right. Okay. Okay, so let's punch that into the calculator. To 3 sig figs, 2.29 moles of CO2. Okay, so notice how we use the molar mass, right, of CO2 to convert between grams and moles. Right? That's a basic function that you guys should learn, which you've learned already in a previous chapter. Right? But now, you know, you're going to do it with molecules, right? Not just atoms. So you're going to see this over and over again. So you really want to make sure that your conversion from gram to mole is smooth, and you can do it quickly, right? So notice that when you go from mole to gram, you're actually multiplying the molar mass, right? And when you're going from gram to mole, you actually divide the molar mass. So as I was saying before, right, the conversion factor can be written in whichever way that's going to serve you in doing the problem solving. Okay, so sometimes 44.01 needs to be on top, and sometimes it needs to be on bottom. Okay, and you don't have to memorize this, right? If you just follow the unit analysis method of problem solving that we've been doing, the desired unit should always go on top, and the one that you don't want, right, needs to cancel, and so you need to put them opposite side, right? So mole is on top here, and mole is on bottom here, and so that's why they cancel. All right. Okay. Let's do another one. Okay, so what if you're asked this question? How many grams of water are there in 6.2 moles of water? Well, we know that water is H2O. Okay, so anytime that you see, you know, a question asking between grams and moles, you know you need to know the molar mass, right? So figuring out the molar mass of water, remember, you're going to add up each individual atom. So there are 2 hydrogens, so 2 times, you can look in your periodic table. Hydrogen is 1.008 grams per mole, plus oxygen, which is 16.00 grams per mole, for a total of 18.02 grams per mole. Okay. So again, remember this line right here, this slash, is the same thing as the divide sign. So on one side, you have 18.02 grams. On the other side, you have 1 mole, right? That's your now your conversion factor. Okay. So you're going to use that conversion factor to answer this question. Always start with what you're given, 6.2 moles of H2O. Then you're going to do that. Remember, that line is the same thing as this line, right? And you're just going to think about, okay, what does the question want as unit? It wants grams of water. Okay, right? How many grams of water? So I need grams on top, okay? So when I'm looking at this molar mass and my conversion factor, what is the number that's tied to grams? 18.02 grams. So that should go on top. And what's the other side? On the other side of the slash is just 1 mole. So that goes on bottom, right? And what are we talking about? We're talking about water. So be very deliberate and specific about the units that you're going to use. It's going to be really helpful for you when you're doing these kind of problem solving, right? Grams of what? Grams of water. Mole of what? Mole of water. So you can see that mole of water cancels, and all you have left is grams of water. Okay, so let's punch that in. Okay, so to 2 sig figs, how I have it here, this would be 110 grams of water. Or if you want to put it into scientific notation, make sure that you have 1.1 times 10 to the second grams of water, right? Either way, both of these numbers are representing 2 sig figs, right? Because that's what we need is 2 sig figs here. Okay. Okay, so now let's do it the other way around. Okay, what if we have 345 grams of water, and we're asked how many moles of water that is. Okay. So now our conversion factor, as you can see, we want mole on top. So that molar mass right there, the mole needs to be on top. So where's the number? What's the number associated with mole? Just 1. So 1 mole of water on top. And then the other side is the 18.02 grams of water. That needs to be on bottom because you want grams of water to cancel. Okay, so let's punch that in. 345 now divide by 18.02. And that's 3 sig figs, right? This is 4 sig figs, this is 3. So we need to round it to 3. It's 19.1 moles of water. Okay. So that's really, pretty much it for going between grams and moles. A review again, you guys have seen this before. Now, on to a new topic, another conversion that you can do from here. What if, let's say, a question asks you, how many moles of hydrogen are in 3.0 moles of water? Okay, so now we start with 3 moles of water, right? And what we're going to do is we're going to count the amount of hydrogen there are in water, which is easy to see from the chemical formula. So you don't have to look anywhere else but the chemical formula to answer this question. So now it wants to know the moles of just hydrogen in water. Well, in each water, how many hydrogens are there? 2, right? So per 1 mole of water, there are 2 moles of hydrogen. Okay, and since we want moles of hydrogen out, we want to put 2 moles of hydrogen on top, right? 1 moles of hydrogen on top. So we're saying there are 2 moles of hydrogen in 1 mole of water. Okay, just a true statement about counting hydrogens. That's all you have to do here. Okay, just notice the moles of water will cancel, and then 2 times 3 is 6. Okay, so your answer will be 6.0 moles of hydrogen, right, in 3 moles of water. That makes sense, right, guys? Because we got 3 moles of water, but each water has 2 hydrogens, then you actually got 6 moles of hydrogen. That makes sense, right? And so what we're using here to solve this problem, we call it a mole-to-mole ratio. You guys see why that is? Because this is literally a ratio of mole of one thing to mole of another thing, right? So you're basically counting, right? There are two per 1 mole of water, there are 2 moles of hydrogen, right? Mole-to-mole ratio. Okay. So how do you know when you need to use a mole-to-mole ratio? It's when you're being asked for mole of A, for example, from moles of B. Okay, so you ask about moles of something else given mole of something, right? So you can relate moles of one thing to moles of another. Okay, so the problem solving strategy that we've been doing, I'm going to summarize it for you guys. And you've seen this before. We're going to expand on it. This type of problem solving, right? It's like a roadmap because you're going from one unit to another unit. And it's kind of like driving, right? Driving from place A to place B. And you need a roadmap in order to do it, right? If I want to go to, say, San Diego from San Francisco, that's one route, right? But if I want to go to Los Angeles from San Francisco, then that's going to be another route. So it's kind of like that, right? When you're doing unit conversion and you're going from this unit to this other unit, well, you need a certain road. And so we can summarize it like this. We can start at atoms or molecules of A, and we can convert to mole of A through Avogadro's number, okay? So we've done that already in the previous chapter, right? And now with molar mass, we can go from mole of A to gram of A through the molar mass of A, right? And that was what we had been doing back and forth with grams of to moles of water and grams to moles of CO2 in our earlier example, right? Now, the new thing is it's asking, like that previous problem, it's asking how many moles of hydrogen are there in 3 moles of water. Oh, so now it's asking you to relate mole of one thing to mole of another thing. We'll call that B, right? In order to go from mole A to mole B, you will need what's called the mole-to-mole ratio. And where do you get the mole-to-mole ratio? Straight from the chemical formula, right? So that makes it really simple. And now on the B side, the B side just mirrors the A side. So from mole of mole of B, you can get to grams of B as well by using the molar mass of B, okay? Or from mole of B, you can go to atoms and molecules of B through Avogadro's number, okay? So that's the roadmap, right? Now, certain questions is going to ask you, grams of A, start at grams of A, and then move to mole of A, and then move to mole of B and stop, right? And so you would do 2 calculations. Some other problems will ask you to start at grams of A, okay, but then end at gram of B, okay? So that means you're going to have to do 3 steps, here, here, and here, okay? So have this roadmap, out in front of you. It's going to help you do these problem solving. I'm going to erase it because I don't have a room, but you guys have that in front of you. We're going to do some problems here. Okay. All right, so let's do let's have an example with calcium nitrate, for example. So we can ask how many moles of oxygen are there in 45.6 grams of calcium nitrate. Okay. And calcium nitrate is CaNO3 Okay. So we need to first get the molar mass of this, right? So let's do that. Look up at our periodic table for calcium's molar mass, which is 40.08. All right, I'm gonna add that to, so you have nitrate here, right? NO3, but you got two of them. So make sure you multiply through. That means you actually got two nitrogens. So 2 times, and nitrogen's molar mass is 14.01 plus 3 oxygen per nitrate, but you got two nitrates. So 2 times 3 is 6. So that's actually 6 oxygens total, and oxygen's molar mass is 16.00. Okay, let's sum that up. (164.1 grams per mole). Okay, right? Everybody should getting that. Okay. So now it's asking us how many moles of oxygen are there in 45.6 grams of calcium nitrate. So look on your roadmap, right? Where are we starting? We're starting with grams, and we can call this one A, okay? And then it's asking us to stop at moles of oxygen is different than calcium nitrate. So it's asking us for moles of B, okay? So we can actually write a plan based on your roadmap, right? And this is how I would suggest you guys to do all problem solving, right? Look at the key pieces of information that's given to you. Write a plan first before you do the execution, okay? So from the roadmap, where do we start? We start with gram of CaNO3 to calcium nitrate. Well, the only way to go from gram, right? The only path there is to mole. You look on the roadmap, right? So next stop is calcium, moles of calcium nitrate. Okay. And then finally, we can use the mole-to-mole ratio to get from moles of calcium nitrate to moles of oxygen. Okay, so we got a game plan. Now we just execute. We start with 45.6 grams of CaNO3 2. All right, and then we're going to convert. Remember, desired unit on top. We need to get to moles of calcium nitrate. So when we look at our molar mass, the mole has to be on top, right? What's the number tied to mole? Just a 1 in front, right? An implied 1. So you go 1 mole of CaNO3 2 on top. And on bottom is, on the other side, right, of this divide sign is 164.1 grams of calcium nitrate. So notice, right, that cancels. And then one more step, we go from moles of calcium nitrate to moles of oxygen. Okay. All right, so we need moles of oxygen on top. And here we need to get a mole-to-mole ratio. And where do we get that? You guys remember? Just straight from reading the chemical formula. How many oxygens are there in calcium nitrate? Can we just count? 6 total, right? So we can say there are 6 oxygens, right? Or 6 moles of oxygen, and that should go on top, because that's the desired unit, in 1 mole of calcium nitrate. Pretty straightforward, right? You're literally counting. There's 6 oxygens in 1 calcium nitrate. And you just use mole as the unit, right? So there's 6 moles of oxygen in 1 mole of calcium nitrate, right? So let's punch that in. It's 1.67 moles of oxygen. 3 sig figs, right? Because of this number. So I round to 1.67 moles of oxygen. Okay. All right, let's do another example. We're still going to look at calcium nitrate, but let's change this. Instead of oxygen, what do I want to know about nitrogen. Okay, how many moles of nitrogen are there in 45.6 grams of calcium nitrate? Okay, so again, I would start with my plan, right? Which was grams of calcium nitrate is what I start with. And I gotta go to moles of calcium nitrate. And then I go to moles of nitrogen this time, okay? So basically the first step is exactly the same as the last problem. Start with what's given, right? 45.6 grams of calcium nitrate. I want to get to moles, so mole should go on top. So 1 mole of calcium nitrate over 164.1 grams of calcium nitrate. Okay. And then I need to get to moles of nitrogen. So this is where I go from mole A to mole B using the mole to mole ratio. I'm literally just counting how many nitrogens are in calcium nitrate. There are 2 moles of nitrogen per in 1 mole of calcium nitrate, right? It's just a true statement. That's all. And we punch that in. So 3 sig figs again, I would have 0.556 moles of nitrogen, right? Again, 3 sig figs because of that number. Okay. So as you can see, depending on what the question is asking, all you have to do is count, right? The number of atoms that is inside that molecule. Okay, and that's how you get your mole to mole ratio. Okay, let's do another one. All right. So now this question asks, how many grams of potassium are in 15.4 grams of potassium sulfate, K2SO4? So of course you're gonna need the molar mass of K2SO4 first. So let's calculate that. You got 2 potassiums. 2 times, let's look on the periodic table for our potassium's molar mass is 39.10 plus sulfur's molar mass is 32.06, I believe. Yep, 32.06. Plus, there are 4 oxygens, so each oxygen is 16.00. Okay, so what do we have when we sum that all up? $174.26 grams per mole. And again, as I was saying, right, when you're doing molar masses, 2 decimal places is great to round to. And yes, just double checking that the molar mass is right. Okay, so we got 174.26 grams per mole. Right. Now we write our plan, right? Use your roadmap. You are starting at grams of, we can call this A, right? Doesn't matter what you call A or B, right? So we are starting grams of A, just grams of K2SO4, okay? And there's only one route to go from grams. Grams gotta go to mole, right? Mole of K2SO4, okay? But you want to end at grams of B, don't you? So on your roadmap, right, you got to get to grams of B. So you got to go to mole of B first. So mole of potassium first before you can get to grams of potassium. Okay. So very straightforward when you follow that roadmap, right? That's why it's so useful. That's why I showed it to you guys. So really, you really want to be doing your problem solving like this, right? Okay, so let's execute. We got a plan. Let's execute 15.4 grams of K2SO4. We need to get to moles of K2SO4. Okay, so that means mole got to go on top. What's the number tied to mole? That looks just, that's an implied 1, right? And then on the other side of the slash, right, that divide sign is 174.26 grams, right? And it makes sense that we want that on bottom because we want this to cancel out. Okay, so now we're here. We have moles of K2SO4. We need to get to moles of K. How do we do that? We're going to count, right? How many potassiums there are in K2SO4? How many are there? 2, right? So you're gonna put 2 moles of potassium on top because that's the desired unit. On bottom, 1 mole of K2SO4. Okay, so what you're saying is there's 2 moles of potassium and 1 mole of K2SO4. Cancel. Okay, and then one more step. We need from mole of K to gram of K. Oh, so on your roadmap, right? How do you go between moles and grams? You need a molar mass. This time, we need a molar mass of potassium. Okay, so we can just look that up. Molar mass of potassium is 39.10. Okay, so 39.10 grams per mole. That's the molar mass of potassium, right? So which number is going to go on top? Well, we do want gram, so we want to make sure that 39.10 grams of potassium is on top. 1 mole of potassium is on the bottom. Okay, and then we calculate. To 6.91 grams of potassium. Okay. Yep. All right. Let's do one more. We'll do just one more for you guys. And then you should go and practice a bunch of these on your own. Make sure that you can do it. Okay, so let's make up another compound. Okay, so how many grams of, let's say, phosphorus are in 124 grams of calcium phosphide. Okay, calcium phosphide, Ca3P2. Okay, all right. So again, we need the molar mass of Ca3P2. So let's calculate that first. Calcium's molar mass is 40.08. And we got 3 of them, right? So that's why I'm multiplying. And then plus 2 times phosphorus molar mass. Which is 30.97. Okay, sum that up. $182.18 grams per mole. check it one more time. Okay, and then we write our plan. We got grams. We can call this A, right? This is grams of Ca3P2. We are going to convert it to moles of Ca3P2, right? And what does it want at the end is grams of phosphorus, right? P, phosphorus is P. But that's basically mole of B, okay? So you're going from mole A to mole B. So mole of phosphorus, and then 2 grams of phosphorus. Okay. So you start with what you're given, 124 grams of Ca3P2. You need to get to moles. So look at the molar mass. You want mole on top, right? So 1 mole of Ca3P2 over 182.18 grams of Ca3P2. Okay. Then we get to moles of phosphorus. We need to do that next. So remember, how do you get from mole A to mole B? A mole to mole ratio, and you're just counting the number of phosphorus in calcium phosphide. How many phosphorus are there? 2. So we have 2 moles of P, right? And moles got to be on moles of P on top, and 1 mole of Ca3P2 is on bottom, because that's what you want to cancel. Last step, you want to get from moles of phosphorus to grams of phosphorus. So you'll need the molar mass, right, of phosphorus, which is 30.97. Molar mass of phosphorus is 30.97 grams per mole. Okay, so we know that we need grams on top. So 30.97 grams of phosphorus on top over 1 mole of phosphorus on bottom, right? And that's equal to 42.2 grams of phosphorus. It's a 3 sig figs because of this number here. So we round to 42.2 grams of phosphorus. Okay, yeah, so that's it. You guys go and practice a whole bunch of these. That's the only way to master is when you guys put pencil to paper and get, knock a few of these out. I'll see you guys in the next video.